sometimes the interest rates are vary with time. Remember, so before this scenario, all we learned and all we have seen is you got the same interest rate every year or every month, every interest period. Okay, so the I percent does not change over time. But in reality, sometimes you have a floating interest rate. The I percent is different every year or every time interesting compounding period. Okay, that's the reality. And so here is an example, like the student loans or any home purchase loans, okay, or car loans. It could be a floating rate. Sometimes you are given different options. You can use a fixed interest rate, or if you can go with floating rate. Okay, so whenever the market change the yearly interest rate, and then you have to pay a different interest rate for that year. So that's another scenario we're looking at. And here is the example. So Shia Smith is a senior who used the Stafford loan program to borrow $4,000 4 years ago. 4 years ago, okay? So it's an earlier time. So she borrowed $4,000 4 years ago, and at that time the interest rate was 4.06% per year. And she borrowed another $5,000 3 years ago at another interest rate, okay? And also 2 years ago she borrowed $6,000 at a different interest rate. And last year she borrowed $7,000 at another different interest rate. So in the past 4 years, every year she borrowed some money from the loan, okay, with different amounts and also with different yearly interest rate. That's very normal. Now she would like to consolidate her debt into a single 20-year loan. Okay, so now she decided that I want to pay off all the money I borrowed in the past 4 years in 20 years. And in the 20 years, she had a fixed interest rate, which is 5%. So that's her cash flow diagram, and that's her plan. And now the question is, if Ashia makes annual payments, which means she wants to pay it every year with the same amount, so she wants to pay it as annuities, right? If she wants to do that to repay her total debt, what is the amount of each payment? So what is the annuities in the next 20 years, so that she can pay off all the money she has borrowed in the past 4 years. Okay, so in this cash flow, you can imagine in the past 4 years, you have different interest rate every year, different cash flow amounts every year. And starting from present to the next 20 years, you're going to have the same fixed interest rate, 5%. But you want to somehow distribute all the earlier cash flows to annuities so that you can pay off all of them. Okay, so that's the case. First thing, let's draw the diagram first, okay? So the cash flow diagram, if we are looking at this problem from Ashia's perspective, you can draw the cash flow diagram. Okay, let me find out my notes. Okay. So remember we have like past 4 years, okay? So this is the timeline is gonna be a little bit different than what we have done before. So we can put our present year here. And then the year before the present year will be minus numbers, which means they are a past time. Okay? And in the past time, every year she borrowed different amounts of money. So 4 years ago, she borrowed 4,000. So that's the money comes into her account. So that's receiving. So arrows going up. And the interest rate is 4.06%. And 3 years ago, she borrowed another 5,000. Interest rate is 3.42%. And 2 years ago, she borrowed 6,000. Interest rate is 5.23%. 1 year ago, she borrowed 7,000. Interest rate is 6.03%. And after that, Xia's plan is to repay this debt, okay? And she wants to pay the same amount as annuities every year for 20 years. So after the present time 0, you're gonna have year 1, year 2, 3, 4, 5, 6, until 20. Okay, and every year she wants to pay the same amount. So that's the money, that's the spending. Okay, so it's the arrows going downward with the same amount. Well, we don't know how much is it, so we just draw the shorter annuity, and A is unknown. Okay, so that's the cash flow for this problem. And how do we calculate the annuity? That's the question. Okay, so the way we do it is we first convert all these cash flows to the present time. So we can calculate something P0, okay? And P0 is gonna be the equivalent value of all these past cash flows. And then we distribute this P0 to every year, so that we convert the p-value to some annuities. So that's the logic, okay? So first, we convert cash flows in the past 4 years to P0, okay? And second, we convert P0 to annuities. Clear? Okay, so now the first question is, how do we convert the 4,000, 5,000, 6,000, 7,000 to a present time? Because they have different interest rate. Okay, so the way you do it is you do it one by one at a time. Okay, so the first step, you want to convert this 4,000 to 3 years ago. Okay, so convert the 4,000 to 3 years ago. And plus the amount of 5,000. So that's gonna be the total amount of cash flows at the 3 years ago, okay? We can write it as some value at different time, but it's minus 3. So future value minus 3 means it's earlier than the present time. Okay, that's just a label thing. But the meaning is the total cash flow 3 years ago. Okay. So that value should be the 5,000 already at the 3 years ago plus the value converted from the 4,000. Okay, so the value converted from the 4,000 is you have 4,000, which is an earlier time. You want to convert that to a future year, just next year. So it's to find F given P. Okay, so you want to use the 4,000 times to find F given P, and I is 4.06%. Number of compounding period is only 1. So that is 9,162.40. Okay, so now you convert the 4,000 to the 3 years ago, and then you add up the 5,000 already happened at 3 years ago. That's the total cash flow happened at 3 years ago. Okay, and the next step is to convert the total value of 3 years ago to 2 years ago. And plus the 6,000 borrowed at the 2 years ago. So you're gonna have the total cash flow 2 years ago. You can label it as F minus 2. Okay, so F minus 2 is gonna be, so now you want to convert the 9,000 something 3 years ago to 2 years ago. So that's to convert some present value to the future value, right? So still you have 6,000. That's the amount you already have at 2 years ago, to plus some converted value from the 9,000 something. Okay, so it is to convert a present value to a future value. So you want to use the equation of the P, which is 9,162.4 times the factor to find F given P, and interest rate, now it's 3.42. Okay, and then this amount is and that is your cash flow. Okay, we don't have to write that. Okay, so then you need to convert this F minus 2 to F minus 1. So convert all the cash flow to 1 year ago. Okay, so convert this 15,475 cents to 1 year ago plus the 7,000 already happened at 1 year ago. That's your total cash flow 1 year ago. You can label it as F minus 1. Okay, so F minus 1 is gonna be 7,000. You don't have to convert it. And 5,000. That's the total amount happened at the 2 years ago. You want to convert that to a future year. So it's P times the factor, find the F given P. Interest rate is, again, different. So it's 5.23%. Period is 1. Number of period is 1. And this value is 23,285.13. Okay, and then you want to convert this to a present time. Okay, that's the time you have the P0. Okay, so convert this 23,000 something to present time. So that's gonna be P0. Okay, so P0 is 23,285.13 times a factor. It's still, you want to convert a previous value, so 1 year ago, to a later time, so it's to find F given P. And interest rate is 6.03%, number period 1 year, so that is 24,689.22. Okay, so until now, you have converted all the cash flows in the past 4 years with different interest rates to the present time. You got the P0. So this part is very complicated. You can see. And also, if you look at this interest rate, they are not the interest rate tables you can find out in the Appendix C. So basically, you don't for this interest rates that you cannot find out in the table in the tables. You have two options. You can use the equations instead, okay? Or there are some online calculators. Online economic calculators. You can input this non-integer interest rate to calculate a factor. Okay, that's the two options. So in our class, we won't require you to calculate this type of interest rate problems. But you need to understand, if you have various interest rates going on every year, the way you calculate is you need to calculate year by year. You convert the cash flow from previous year to the next year with that year's interest rate. and then you plus the cash flow already happening in that next year, and then you convert that total amount to another next year. So that is sequentially, you're gonna accumulate these cash flows back to compound them to a future time. So that's the logic. And in this case, now we have converted all these 4 cash flows to the present time. The next step is to convert the present time value to annuities. So now it's easy. You just use the equation A is P0 times a factor, which is to find A given P, interest rate, and the number of periods. Your P0 now is 24,689.22 times the factor is A/P. I is now fixed. Okay, so you can convert it directly. So 5%, how many years? You got 20 years to distribute. So now the value is 1,980.08, which means Ashia needs to pay this amount every year for 20 years so that she can repay all the earlier debts.